Hi guys, today's our last day of this section, chapter 8, section 4. So on Monday, we simplified a single fraction. Yesterday, we multiplied two fractions together. Last thing we gotta do is divide two fractions. And all of these problems are very similar. They're just like adding on one extra step. So for division, the extra step is we don't ever divide fractions. That's not how we deal with that. And so if you see a division problem, you're going to instead multiply by the reciprocal. What that means is you're going to change the division symbol into a multiplication symbol. And then reciprocal is taking a fraction and flipping it upside down. Specifically, you want to flip the fraction that's immediately after the division sign. So don't flip the first fraction, flip the second fraction upside down. And then after that, it's a multiplication problem. And that's what we were learning about yesterday. Here's a visual of what that looks like. So here I have two fractions which are being divided. So I'm going to change the division to multiplication. I'm going to keep the first fraction the same, and I'm going to flip the second fraction. So it was r over s, now it's s over r. And then you continue with the steps that we have been doing. Our first example for today is monomials. There's no adding or subtracting, so we don't have to do any factoring. Because we don't have to do any factoring, we're going to go straight into solving. So I'm going to change the division sign to multiplication, and I'm going to flip that second fraction upside down. Now we are still going to be doing restrictions today. And restrictions, there's just going to be more restrictions today. So like every day, it feels like we've gotten more and more restrictions. So when you're doing your restrictions, anytime a variable is in the denominator, it can be part of the restrictions. So you're actually going to have to check for restrictions twice. You'll check for restrictions in the original question. In the original question, I have an a and an x in my denominator. So a and x cannot equal 0. But now, after you change it to a multiplication problem, you have a new denominator. So you have to check and see if there are any new restrictions. So based on my multiplication problem, I also need to say that y cannot equal 0. So again, check in the original question, and then after you flip that second fraction upside down, check and see if there are any more restrictions. At some point in time, every letter was in the denominator, and so every letter needs to be part of the restrictions, and we say that they cannot equal 0. All right, let's start canceling. So it does have to be a multiplication problem for you to cancel. You cannot cancel when it's a division problem. So make sure that you've changed it to multiplication first. And then in this problem, I'm going to cancel my 6 and my 3. 6 divided by 3 is 2. I can cancel my a's. Look, in the original problem, we couldn't cancel the a's because they were both on the bottom. But once I changed it to multiplication, I could cancel them. I had 3 on top and 2 on the bottom. So the 2 on the bottom canceled out 2 from the top, leaving me with just 1. For my y's, I have one y on top and one y on the bottom. Those are just going to completely cancel out, so we won't have a letter y in my final answer. And then your x's can't cancel because now they're both on top. In the original question, there was one on top and one on the bottom, but now that it's this multiplication problem, they're both on top. So we can't cancel our x's. We're actually going to end up multiplying our x's together, and it's going to become an x squared in the final answer. So for my final answer, I got 2a x squared. Everything canceled out of the denominator, so it's not a fraction anymore. It's just a nice whole number. All right, let's try one example where we have to factor. Now, because of our restrictions, I am actually going to factor this right now as is. I'm going to leave it a division problem, and I'm going to factor everything. 3 of these are factored using Xbox, and then the top of the second fraction is factored using difference of squares. So here's what I got after I factored. Don't forget, you can go back and watch old factoring videos if you don't remember how to factor. Or I did post an optional Delta Math assignment. You don't get any credit for doing it. It's just there if you need to practice. So if you are discovering that you don't remember how to factor and you want to practice some factoring problems that are just factoring, that's there for you. You don't have to finish it. You don't even have to do any of it if you don't want to. And you could totally do more than what I assigned because it's just there for practice. All right, so right now I'm done factoring. I'm going to start looking for restrictions in the format that it's currently written in. So for my restrictions, on the bottom of the first fraction, I get x cannot equal positive 5 and x cannot equal positive 3. And then on the bottom of the second fraction, I get x cannot equal negative 6. And this one's going to be x cannot equal positive 3 again, but like I already wrote that down, so I'm not going to write it down again. So these are my 3 restrictions right now. Now I'm going to change it to multiplication, and I'm going to take the reciprocal of the second fraction. And here I need to check for new restrictions because I have a new denominator. So looking at the bottom of my new fraction, I have 2 more restrictions. X cannot equal positive 2, and x cannot equal negative 2. So I'm going to add 2 more to my list. Okay, so your shortest list is going to be simplifying a single fraction. In the middle, we have our multiplication problems. And then the division problems usually have an incredibly long list of restrictions because there's so many things in the denominator. All right, I'm going to change the slide so I have some more space for my canceling. Okay, so this is what we ended with on the previous slide. Before I start canceling, I noticed that I have a subtraction problem with the same numbers and same letters, but it's in the wrong order. So I'm going to go ahead and take out that negative sign from my denominator so that I can get that subtraction problem in the correct order. The negative sign should always be in the front. So right now it's in the front of the second fraction. When I write my final answer, I want to push it all the way to the front of the entire answer. If you leave it in the middle, it's going to change it from a multiplying problem to a subtracting problem, and that's not good. All right, we can start canceling now. So I have my x minus 5s, my x minus 2s can now cancel, and my x minus 3s can cancel. And again, for the final answer, make sure that you put that negative sign in the front. Do not distribute it. Leave it factored. This concludes today's video.